The orbital structure of thiophene. If we look at this molecule, we see 4 carbon atoms are here. So we can write down the electronic configuration of carbon 6 like this. 1s2, 2s2 and 2px, 2py, 2pz, 2px and 2py having 1 electron and 2pz is empty. In hybridization state, 1 electron from here jumps here, so we get the configuration like this: 1s2, 2s1 and here in 2px, 2py and 2pz having 1 electron each. Now these 1s and 2p orbital hybridize and form 3 sp2 hybrid orbitals having 1 electron each and 1 pz orbital having 1 electron. Similarly, we look at the sulfur atom, sulfur 16. We can see in 3s 2 electrons, 3px, 3py and 3pz. Like this. When it goes under hybridization, 1 electron from 3px jumps into 3pz orbital, leaving 1 electron here, 3py and 3pz. 1 electron here and 2 electrons and 3pz. Now these show hybridization. After hybridization, new 3 sp2 hybrid orbitals are obtained having 1 electron each. One is having 2 electrons and another 2 having 1 electron, and 3 pz orbital having 2 electrons. Now 1 carbon atom with hydrogen atom forms sigma bond So these 3 hybrid orbitals of carbon forms 3 sp2 hybrid orbitals found at the distance of 120 degree in one symmetry. Now one of these sp2 hybridized orbital axially overlaps with 1 hydrogen atom forming sigma bond. sp2 hybridized, sp2, sp2. Similarly, this carbon atom hybridized overlaps with this sp2 orbital, and its one sp2 orbital axially overlaps with hydrogen atom. Similarly, here sp2 hybrid orbital of this carbon atom and another carbon atom axially overlaps, forming sigma bond. Here also with one hydrogen atom. Another sp2 hybrid orbital overlaps with the sp2 hybrid orbital of carbon atom. This carbon atom having sp2 hybrid orbital or axially overlaps with hydrogen atom, forming sigma bond. sp2 hybrid orbital having lone pair of electrons is in this axis only, and pz is perpendicular to this, having lone pair of electrons. If we draw the pz orbitals of these carbon atoms, these carbon atoms having one electron each, sulfur atom is having in sp2 hybrid orbital one lone pair of electron, and its pz orbital is having lone pair of electrons also. So these 4 electrons from these 4 carbon atoms and 2 electrons from sulfur pz orbital, they overlaps sidewise. So if we can see the axis of carbon and sulfur in the symmetry of this board, we can see that perpendicular to that is above and below of that board, these pz orbitals overlaps and they form a charged cloud above and below this molecule, and electrons are 6 pi electrons, 2 here, 2, 3, 4, 5, 6. Pi electrons are delocalized, giving the property of aromaticity to this molecule, and they sidewise overlap in this manner. Similarly, these also overlap. and giving the molecule the shape like this. In these orbits, the delocalized electrons revolves, giving them aromatic property. These sp2 hybrid orbitals are not in this plane, so they are not involved in this orbitals. So because sulfur is more electronegative than carbon, that's why these are slightly distorted. So this is the molecular structure of